Hey YouTube, how is it going? I hope all is well. Yes, we are back to our old ways again. Well, sort of. This is just something to kind of show you what's going on here. So obviously you can see here we have the chassis. We've got a ginormous transformer over here to my left, and we have a nice reasonable size 50-watt transformer over here to my right. Don't mind my mascot. He's very friendly. Trust me. Zab, Team YDNA in the house. Thank you guys for coming in. This will be, I'm just going to put it right off the bat, this will be a semi-painful video because you're going to essentially watch me design an amp from scratch. More or less, I'm going to try to show you not only what this build will be, but just kind of how you actually come to the decision on these parts. Now, if you were a member of my channel, you would have known the other day why these parts were selected. Tone Priest, how's it going? Thank you for coming in. Mainly because I did a video that kind of gave you a rough idea of why you would select this and etc. etc. But the rough consensus is that if you are shooting for a 50-watt amplifier, you basically square the voltage that you would have on the plate of your tube, and then you divide that by the primary impedance of your output transformer, and that will give you the wattage that you should be able to theoretically achieve. Right? Makes sense? So objectively, you're just trying to find some series of numbers. So the easy way that I have found to come to the decision on what power transformer you need is to just kind of shoot a number in the dark. Start at 450 volts, right? And let's kind of just do something here. I'm going to go over to the desktop. I hope this is still going to work here. I think it is. Yes, it is. All right, good. I'm going to turn on Mr. Calculator here. And there it is. Nice. Okay. So you see the calculator. So we're going to start with some round number. Doesn't matter what it is. We just have to come up with a number. We're going to say 450 volts, right? So that's what we're going to assume is the voltage that is on the plates of our output tube. Okay? And then we need to know what our output tubes are capable of. So in this case, we're shooting for a 50-watt amp, so we know that we need two tubes that are capable of at least 25 watts each. EL34s are a perfect example of that, so we're going to go with EL34s. So we know we can hit 50 watts as a target. Cool. So now what we need to do is just square that number. That's very handy for us right there. Cool. It gives us some large number. Now we're going to divide that number by the primary resistance of our output transformer. Okay? What is that? Well, the one I'm using today is 3200 ohms. So you divide that by 3200. You get 63 watts. That's assuming we had 450 volts. Hey, Offset, how's it going, my man? Thank you for coming in. So that assumes that we have 450 volts on the plate of our tube. All right. That means theoretically we should be able to reach 63 watts of power. Well, that's a little bit more than we want, and that's obviously over dissipating our tubes by a significant amount. So we know that we don't want to go that high in voltage, or we need to go larger in value for our primary impedance. So let's just clear that and come back around on that. So 450 volts. So we're just assuming, again, the same voltage on the plates. Square that up. And then we're going to divide it by some larger number. Let's just round it out to 4K, right? 4,000. So that equals 50.625. There you have it. So ideally, if you were shooting for 50 watts, this is probably about as close as you could get it. If you had a 450 volts on the plates of your tubes, you would shoot for a 4K output transformer, a 4K primary impedance output transformer. Okay, that makes sense? Okay, that's cool. So now we know what tubes we're going to use, and we know, what tubes we're going to use, and we know what output transformer we're going to use. So what does that have to do with this guy here? Well, we've talked about it in another video before, where you basically take the numbers that exist on this thing, and if you look very closely, I'm going to try to lift this thing up. It's pretty heavy, but focus, you fack. See how it says 600 VCT? Okay, 600 VCT means 600 volts to center tap. That means that there's 300 volts on one side, a 0 volts, tap, or center tap. That's one of these red yellow wires here like this, right? And then another 300 volt tap. That's what that means. So if you're using a solid state rectifier, which most of us are, doing tricks on it. There we go. Phantom Boner, there you are. Thank you for coming in. Okay. So yeah, you got that 300. If you're doing solid state rectification, then, hey, Bindi, thank you. Then you would times that 1/2 of the transformer, so 300 volts times 1.4. So let's look at that and see what that would be. We're going to clear everything. So if we had 300 volts and we times that by 1.4, we would get 420 volts. It's a little bit shy of our 450, isn't it? So, and that is with no draw on the amp whatsoever. That is just static draw, right? That doesn't do us much good, if anything. So what do we need to do? Well, we need to just fudge the numbers a little bit more. That 1.4 ain't going to change, right? So if we want to get up to 450, we know that we're probably going to be shooting for a 350. So let me clear that out. So 350, again, this would be a 700 volt VCT power transformer that we're talking about here. And then we're going to times that by 1.4. What do we get? 490. And you're going, Luke, that's significantly hotter or higher than 450 volts. Again, keep in mind, this is before that there is any kind of draw on the amplifier, right? So that means that the tubes aren't in it, nothing's happening. That's just the amp at idle with nothing going on. As soon as you put the tubes in and get everything idled and everything's running the way it's supposed to be, this will likely drop down to roughly your target voltage. The exact percentage amount is based on a bunch of factors. Some of it has to do with how stout your power supply is, so how large your coupling caps are, and how stout your power transformer is. If you go with too low of a value or milliamp rating of a power transformer, this number will sag even further down below your, target voltage. So in my case, I have an extremely stout, and I mean extremely stout, power transformer for this build. Getting one that produces the same voltage at even the milliamp rating that I would need specifically for this amp, it would actually honestly be about the same size. So I tried to pick something that was going to fit multiple amp topologies, and this is what I came up with. So there we are. That gives us a rough idea. So now we know we have a 300, 0300. I'm going to end up with about 420 volts, raw volts. And I am suspecting, based on that I will probably, because of this, how stout this is and the fact that we're going with solid state rectification in this amp, that I'll end up right around 400 volts, all said and done. I don't think it's going to drop much, if anything. If I'm lucky, I'll end up at 410 volts. I factored it at 400 volts. So if I have 400 volts on the plate, we're going back again over here. If I have 400 volts on my plates and my tubes, right, and I square that, and then I divide that by 3200 ohms, because that's the ohms or primary resistance of my output transformer, what do we get? Exactly 50 watts. What do you know? How convenient is that? Now, that is, of course, just a rough number. It might be a little bit lower than that. It might actually be a little bit higher than that. You can fudge it around a little bit. So you're just kind of shooting for a range, right? Probably 5 watts down from there would probably not be ideal, because you have to keep in mind that this is 50 watts of output power, but that might not be 50 watts of clean power. So even going the other way, where we had the 63 watt thing going on, that might allow you to get a true 50 watts of clean power, but then you are at risk of course, burning up the tube. So you want to try to stick to the target numbers. That is the rough, dirty, easy way to do it. It gets you in the ballpark. And if you have to change, well, buy another transformer and you can skip around a little bit. So what are we doing today? Well, we need to kind of come up with the schematic for this. What I can tell you I've already done is, obviously, I got the chassis here and I got these parts here. I have a rough idea of where they're going to go. This guy is going to go, let's see if I can do it without destroying anything, but roughly in that range. And then this one will go, roughly in there, right? And then the tubes, I'll have 2 EL34s that sit roughly in here. I'll have 4 tubes that sit here and 1 tube that actually exists over here. So there will be a total of 5 preamp tubes in this amp. So With that being said, it is now time to kind of go from there. What I can tell you is I've already kind of done up a what do you call it? A layout. I've already done a layout for this thing. So obviously I know my chassis dimensions and I kind of know the rough dimensions of these things. So I kind of put together a drawing. We will come back to that later. I did that without building a schematic first, and it's more or less, I don't really need the schematic. I'm doing this for you. So the layout, though, I do like having a layout because it definitely helps, especially if you're building an amp that you've never built before. It just helps you kind of navigate all the fun stuff. So give me just a moment while I do something real quick. I want to put this thing away so it's not in my space while I'm banging away on the keyboard for a while. So just a second. All right, and it's also time to take a swig of my Ready Bull. It is Red Bull time. I'm going to pull something up over here too to make sure everything is going good. Beautiful, beautiful, beautiful. Okay, I think I'm ready. Okay, so we're going to come away from this view for a bit, and we're going to go over to the boring part. And you're going to watch me struggle in real time while we bang out a schematic for this. So back to the desktop we go. Thank you guys for being here. I'm telling you, this is going to be brutal. You want to know how this is done? This is how this is done, okay? This is the not-so-fun side of building an amp. So this is why they are so expensive, especially if you start doing custom stuff like this one here. You're paying somebody a lot of time to think about what they want to do, how they can work around their problems, and do stupid shit like what we're about to do. I gave it a silly name for right now. The closest kind of topologies that this amp will follow. Hey, Riley, how's it going there? Is a Dumble crossed over into a high watt. More or less, the output section of this amp will be very similar. It will not be exact, but it will be very similar to that of a high watt. As far as the preamp goes, it doesn't have any resemblance whatsoever to a Dumble, but it kind of has the same number of preamp tubes, and it'll kind of do all of that stuff. So here comes the pain. Exactly. All right, so I like to start with the power supply first. So getting yourself this software right here from DigiKey is key. Get yourself, it's called Schemit. Just get it, create an account, and then get Schemit. Now, when you get this software, you're not going to have a user library like I do. You're going to have to create one. So that means that you're going to have to go through and find all of these symbols that you see here in these menus up here and then populate them by creating a favorite. This software is a little timid in some regards. Makes sense. It's free, so you can't expect anything and everything to work. But I can tell you that Alt, Left, Right, and I believe it's Alt R. Yeah, Alt R rotates your parts, and then you can do Alt V for vertical and Alt H for horizontal and stuff like that. So here's Alt H, right, and then Alt V. You can see there that it just flips the comp 1 to the other side. You can also go back and name these things. So see here it says comp 1. It's probably a good idea to at least somewhat keep track of that as you go along, but I like to actually do it from there all the way down the line. If you go out of order, it's not the end of the world, but whatever you need to do. And then of course we want to have a fuse in line first. So I like putting a fuse in line first. And where did I just see it? There it is. Double pull, double throw. So let me talk about that for a second here. A lot of American companies and a lot of amp companies out there just in general use a single pull, single throw switch. Basically, they just cut the hot line. They also don't put the fuse first. They put the fuse after the switch. Technically, a very bad no-no. In Europe, you're required to use a double pull, double throw like this, where you're breaking both the neutral and the line, or the hot, if you will. So I do it where I just do it to European code. That's really all there is to it. So, and then you can kind of see here, you can draw wires into your things. There we go. And then, of course, you can connect these together, etc., right? Same with this guy here. Click. There you go. So now we've got our earth ground here. This is our safety ground. That's what that's representing. We have our line here, which we have our fuse in place first, and then we have our double pull, double throw switch. Now, I'm not doing this correct with this type of transformer that you see here. It's just one that represents close enough what is going on. So by that I mean it's a transformer and it has, an HT out, and it has something I can use for heaters or something like that, right? A different output. So I use this one just because it's quick and easy, and I can just run the wires out into this like that. So that's kind of how that would work, right? Makes sense? And then you can also move these around. If you use the arrow keys, you can kind of see, but it doesn't center up the way I'd like, so we're just going to leave it right there. No big deal. Yeah, in Europe, it can be plugged in both ways. I'm not sure exactly what the code is, because some of them do have a ground like pin, I think, but I don't know that all of them do. I know that they usually have just those 2 pins, so that's why they require you to break both of them. So I just like doing it that way. It makes it simple. And in either case. So the next thing that we're going to have in line is our diodes. So let's get some diodes. I think they might probably be near the top. There it is. So we need 2 of these guys. So I'm just going to drag 2 of them out. And we want those things to rotate around. So we're going to hit Alt-R. No. Is that Alt-R? If I select it, maybe. There we go. There it is. And we do want them to go in that orientation there. So we're going to go Alt-R. And now I am going to use 4 of these. So I will have 2 in line. So imagine like this, if you will. So you'll have 2 going this way, 2 going the other way. Now what these do, for those of you who do not know, is it basically makes it so it shuts the signal down on the lower going portion of the sine wave. AC is a sine wave, and there's 2 sine waves going across here. They're in opposite polarity of each other. So you make these work together in tandem, so that way they both come together, and the only thing that's left over here is a larger version of a positive, slightly larger version of the positive waveforms only. So it doesn't swing down below 0 anymore. It swings up above 0, but it humps. It doubles the frequency. Get it? Makes sense? I'm not going to draw the center tap in here. Most transformers have a center tap, so do be mindful of that. And when I say center tap, that means that there's a line that comes in the middle of that splits this and goes to ground. So practical reason, yes. All right, so the way that works then is that we're going to go directly into a reservoir capacitor. So that is going to be a polarized cap in this instance here. So we're going to take one of these, and we're going to go like that. I'm going to put it, I think I can get away with it right here. No, I'm going to put it down just a little bit. All right, so the way that this will work is we're going to need at least 3 or 4 of these. So I'm going to go Control C, and then I'm just going to do Control V. And we'll do, I think, let me see here in my head, I got 1, 2, 3, 4, 5. 1, 2, 3, 4, and we need 1 more over here, 5. All right. So, again, I apologize. I'm doing this mostly from memory, so I'm going to try not to go to that schematic that I have over there. If I do go to that schematic that's on this other page, it'll mainly be to just reference the pi section. I've never done a fixed bias pi like this one has. So, yeah. Mr. Carlson's Labs, he's got some great stuff. Yeah, there's some funny stuff about diodes. He did expose a neat little thing about that. So now we're also going to get into our dropping resistors. So we're going to drop one here, and we're going to go, not Alt, we're going to do Shift and R, and we're going to kind of put it where we want it. I'm going to say right there, and then we're going to copy and paste this. So we're going to go Control C, and then we're going to go Control V. And there's going to be one in between each of these. Make sense? Easy enough, right? So there you go. Oh, the wife's home. She's saying hi to the dog. Good old buddy. All right, so Now that we've done that, we can start joining some stuff together. Be careful with how you do this part right here. These guys are a little timid. So like if you go and you angle it into this one, you'd have to go from this one into that one. It's really difficult to alter that path after you've already created it. So it's pretty much just easiest to kind of just join them together a little bit. And I'm not going to worry about being hyper accurate with where I place things in the interest of time. As you can see, this one is not very well centered to the other ones. Actually, let's just make it a little bit better centered. So we'll go like that. All right. So then we take this guy and we go like that. We take this guy, we go like that. And then we take this guy and go like, see how it wants to do a different angle? So what you have to do here is left click, and then that'll create that new angle that you wanted. All right, so you see the two diodes go together like this into one. They converge here at our reservoir cap. They go through our first dropping resistor. This makes our primary node here that the center tap for the output transformer will go. This is our dropping resistor that will be for our screen node. This is the screen node decoupling capacitor here. This is the node for the pi section of the amp, and its decoupling cap. And then this is the next intermediate stage, and this is the front end of the amp right there, right? The last resistor that feeds the preamp section. And I think, this is good enough. Now, there are a couple different ways that you can do the grounding scheme on this. Some people will just put little ground lugs that come off the bottom. In the interest of making it look clean and tidy, I usually just kind of do something like this and then join them all down. Now, what I can tell you is that this is not the way that you will actually ground it in the amp, although you could if you wanted. But I'm just saying that it's not technically the right way to do it. And then we will go like this with that guy and there. So there we have that. So now we have our power section. This is our HT rail more or less lined out right here. If I did my numbers right, this should be correct. As I recall, this is correct. And I'm glad to see you guys are chit-chatting there. Thank you. So Red Bull gives you wings. All right, so we're actually ready now to kind of go over the actual preamp. So let's get ourselves an input thing here, and we're just going to put it there, and we're going to get a triode. We're going to put it there. Ooh, do I want to do a triode or a dual triode? This one's simple enough. We're going to use this one. Oh, it doesn't show the freaking, that's that diode, that's why. I don't want the pentode. Where the hell did I see it? I know there's a dual triode in here somewhere. Maybe not. Dual triode, there it is. I just have to look a little harder. Yay! All right, so with this one here, I usually try to line it up so this grid wire there aligns with that there. And they'll shift around a little bit, but I try to make it so all the tubes kind of land in line. But you can see here, these are the cathodes. All right, these two little L bracket looking things there. The little dashes in the middle, those are the grids. This little ziggy-zag WM looking thing there in the middle is the heater. And then each of these two little pins up there at the top, those are the plates, for those of you who do not know. Now, what we do need is a grid stopper and a grid leak. Now, I try to do my resistors in order as you would see it as you go through the circuit, right? So the very first resistor that you're going to touch is going to be your grid leak. So I will tend to take this guy and put that in place, and then I'll grab another one and put it out, and then we'll rotate that. And then that would be our grid stopper, which is a very important thing to have. And because I don't like those running into each other, what I'm going to do is Alt-H, so it goes the other way. There we go. All right. And we'll come back to this side of things here in a minute. But basically what we're going to do is this. Click and click. And we'll move these things around here in a bit once we get there. So, LT Spice. I think this one will actually do a test as well on your circuit. I'm not 100% certain, but I think it actually will test and kind of show if you've got some major flaws. But I've never used it. But But yeah, LT Spice is cool because it actually does kind of tell you, like, for reals what's actually going on. But not today for me. Okay, so the way I run my amp, I do my preamp, I should say. My very first tube is I parallel it together into one. And the way that I pull that off is pretty simple, in fact. I usually start from the bottom. Darn it. Sorry. I usually start from the bottom, so this will be the next resistor in line, and then I'll go to the top for the other half of it. And I think I'm already seeing a problem. I'm going to take this and move it down a little bit. And you saw I just did a click and drag over what I wanted to move down. I need a polarized here for the cathode resistor, or cathode, bypass. And then we need another resistor for our plates. All right, so let's get this where I want it. And then how I do this is I basically run this over and connect those together so they make like a little U shape. And how do I do this before? I can't remember how I did it before. I think I just did kind of the similar thing. I basically join those together, and then these kind of just both go into it, right? I'm trying to think of how I've done it. I haven't done this in a while, as you can probably tell. And then what I'm going to do is Alt-H that so they go away from each other. All right, so what we have now done is created most of our first circuit. We need one more thing to actually complete this very first preamp node here. And I'm going to go rotate. All right, so we're almost there. So this guy I'm going to put right there. This guy I'm going to take and run to there. And then this guy is going to come up and go into there. All right, we have now officially made our first circuit, if you will. We'll come back and put some tabs on these here in a minute, but essentially at this point here, we can consider anything after this point to be another circuit or a different circuit. So the way I like to do this then is to close all this up. So I'm going to take this and go to there. So we want this to be a grounding plug. There it goes. So and then I'll come from this one, go over, and up, click. So now everything's encapsulated there. And then I'll take this and go to that. And same with this. Makes sense. All right. And then we can kind of pretty it up and make things kind of look more balanced or whatever, right? So now we got that. We're going to take this guy, Control C, Control V, and kind of move it somewhere that looks pretty centered to me. So there we go. Ta-da, there it is. That's our first circuit kind of finished up. Let's go ahead and put some tags on these things so we know what is what. So here's a little voltage rail thing. We're going to stick that guy right there and connect it to our first tube. Now this is actually so this would be A, B, C, D, E. I like using letters. You don't have to. You can use whatever you want, but I go with letters. So this is our E node. So we're going to say the name is E. You cannot have copy. Well, for these ones you can have copies, but for resistors, be mindful you cannot have the same resistor value twice. You can't have R8 twice. So that's why it's kind of important to go in order, because it makes it a lot easier later to get these things in the right order. Yeah, DigiKey's not that bad, and I'm not going fast by any means because I'm literally explaining things. And then we'll take this guy and we'll put out a few more of these things. Right there, sure, why not? We'll Control C, and then we'll go Control V, 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 and V. All right, makes sense. And we'll move these guys into place. Man, that one landed right on the money. All right, and then the same. You just take that, connect it. It's going to make me work. I think that'll work. There it is. Okay. Give yourself a little more space. It might make it easier sometime for these things. And uno mas. There we go. All right, so then we can take this one. Same. You have to click these things over here, these boxes, and you can see there all of a sudden it changes over to V-rail. So this one is going to be our A node, all right, and then hit enter. Actually, I don't even think you have to hit enter, but and then I like to move them. It doesn't always put it in the best spot. Name, B node, and I do capitals just because it's appropriate. So whatever. You little brat, get up there. C node. So Boop. There we are. And then up here, D node. And lastly, our E node. All right, so now we've actually technically completed our power rail. All right, so now we're into our second gain stage right now, but we have a tone control that I like to put in there, and volume pot. So there's several different ways you can do that. For me, I do it slightly different because I have a slightly different tone control. For me, I haven't decided exactly how I'm going to do the tone circuit yet, but there will be a tone circuit in there, and it will probably consist of my standard low cut. I don't know what happened. You guys just play nice. Anyway, so because of the way that I do my tone control, I will need a second one of these. And I will Alt-R that over, and you can see here that it just kind of sails over the top. I believe it was Riley, was it you? Or it was Zab was hitting me up about using this. I think it was you, Zab. So definitely worth checking out. I always wire this part incorrectly, but you're more than welcome to do it however you need. I just make it so it's easiest to kind of see what's going on. And more or less what happens is this. I'm going to actually go like that, and then the volume pot goes somewhere up in here, and then the top goes into that, and then this goes down to ground. That will not go down to ground, so I float the this is not wired correctly, by the way. Just know that this is just representing of what it's going to be. The famous Luke tone control. This is my little design right here, my little tone secret. I was saying earlier, one of you guys, I was talking about it anyway. So the value of this pot right here has a large effect on kind of how this circuit reacts. So obviously this will be your small pot, or your cap. This will be your small cap, whatever your small value is. So this is going to be your low value. So whatever you want the thinnest value to be. This will be your large value cap here. So that will be your, how bassy you want it to be. However, the size of this cap or pot, determines how much of this will sail over or away from this part of the circuit, right? Because essentially what you're doing when this pot is fully on, it's just allowing these two to act in parallel with each other. Caps in parallel, sum together. So essentially you're trying to make your upper end option be the largest value you want. So if you want, 0.047, however you break that up, you just want those two, when they're fully on in parallel, to be 0.047. So whether you use 500 PF here and 0.037 or 0.03 over here or something like that, right? Whatever it needs to be to get that value, that's how you do that. But the value of this guy determines how much this one will actually get cut out of that circuit when it's all the way down, if you will. Now, the larger the value, the larger the range that you have from fat to thin. The downer is that the larger the value you use, the more noise you get, right? So you kind of got to play a balancing act between these two values to get your thinnest thin and your fattest fat and what amount of range you want. So that's just my thing for you to ponder upon, if you will. All right, so we got this guy here. I would say that it's wise to probably use another grid leak despite using a pot here. And then it's always wise to put a grid stopper whether you need it or not anyway. So I usually will put both of them in there. So we'll put that there, we'll put that there, and now we need another tube. Now, in this case, I'm not going to put out a dual thing. I'm just going to put out a single triode. And you can see how this will get really big really quick. No, the rules are not changing. It is very simple, and you're more than welcome to post that here. I was going to kind of go over that here in a minute. I kind of brushed over it. Well, I failed to really kind of give this a true introduction earlier, but I think it's kind of clear what this is. So In either case, Alt H. There we go. So now you can see we're starting to build another circuit here. All right. Now you could draw it with one of these guys here and try to build it into that, but I find it to be a little challenging, especially to keep it clean when you're trying to make a concise, schematic. Whether this is V2A or V2B, the downside is this one doesn't let you put V2A. At least I don't think it does. Yeah, it doesn't let you put V2A. It doesn't make any sense why you can't put V2A. You can only put, something else. It makes no sense. See there, it's saying you can't do that. It's really weird, but in either case, you go V1, V2, V3, V4. As a builder, you're just going to have to know it's V2A, V2B, whatever. All right, so now we got that. Let's go ahead and start completing this circuit. So a grid stopper is important because you can use it to control high frequency oscillations. You can also use it as kind of a tone control, which is more or less what I use them for in my builds, is a way to kind of manage the tone. If you want to try to build in kind of a mid-range cut, one of these is kind of the way to do it. If you got a lot of bass coming in and you put one of these in and then you use a little bright cap over the top of it, what have you essentially done? You have kind of created a mid-scoop type of sound. So as you start building more and more of these in, you can kind of get more and more of a mid-range scoop. So just, pro tip right there. All right. I hope that makes sense. So now we're also going to need a cathode resistor, and I don't know for sure if I'm going to use one or not, but I may or may not bypass this cathode on this particular tube here. So just be mindful that you don't have to have a bypass cap, but if you want to get a little bit more out of your thing, you might want to put one in there. So there's that. And it looks like what I want to do is go over. There we go. And I think maybe I'm trying to shoot right down the middle of these two here. And that might not work, but we'll see. Whatever. All right. And then we need a resistor up top here for the plate. All right. Makes sense. And I like to try to keep everything in a row. It just helps keep things clean and concise. And you can see here I missed this whole thing by one whole thing. But whatever. More or less, I could have just moved this up one, or I could have moved this up one. But I'm not going to bother with it. We're just going to keep on rolling. All right, so we're going to take this guy, put it there. We need a cap over here to complete this part of the circuit. And we're going to rotate that around. And again, we're going to kind of try to keep it in line there. And I'm going to move it in just a little bit. I think right there will work. All right, cool. And then what I'm going to do is this. I'm going to click, bloop, and then we're going to take that and go into there. And you can see I kind of duffed it on the spacing, so I'm going to see if I can get away with it. Aha, it'll let me do it. Cool. It doesn't match over here, so whatever. We're going to leave it like that. That's fine. Okay, now what you can see now is that we have yet another circuit completed, right? So here's the end of our circuit for this particular triode right here. Okay, does that make sense yet? Is that clear? So it stops right here at this guy. So you do the same thing. You just kind of come around, and in this case, we're not grounding to that guy. We're grounding to our volume pot, and I biffed it. Hold on. I went too far down. I wanted to go to there. There we go. Click, and then this guy will go down. There it is. Oh, and I still duffed it. Hold on. Click. There it is. All right, nice. Control C, Control V, and move it where you want it. Again, I try to keep it somewhere in the middle and in line with the existing one over there. This looks pretty close. There it is. That circuit is now complete other than having one of these guys here. So we'll take that and we'll copy it over here. And I think I need to go up one more. That is correct. And done. Except for we're going to name this one D. Yeah, no, we just want D. There we go. Perfect. All right. Does that make sense? So we're going to continue to do that another 3 or 4 or 5 times. As you can tell, it's going to get and just draw out. In this case, V1B. Well, it's not that it doesn't need to be. It's just that because I parallel the tube, you kind of just got to imagine that it goes around anyway, like that. So in that case, you could say it was connected. So I run my first triode in parallel in all of my amp designs. It's just a thing I like to do. Mojave Amp Design used to do it. There's several matchless amps that would do it. It does a thing. I'm not going to say it's better than a single 12AX7, like the Fender way and Marshall, etc., but it does a thing. I like it because it gives it just a little more snot. So it has obviously two triodes working in parallel with each other. It tends to have a little more oomph, just a little bit more, not a lot, but a little bit. But it drops the noise floor pretty much in half, right? So if you had X amount of hiss and you parallel the two triodes together to run them as one, that amount of hiss would cut in half, more or less. Well, not half, but it would drop significantly. And then, of course, now you've got two triodes running in parallel with each other, and it's a tube, so nothing's exactly exact inside of this thing, and it just kind of adds a little harmonic richness to it. What I notice it as is a little fatter, so thicker sounding, and it kind of has more of a bubbly feel on the fingers. It's got a nice glue to the fingers. That's what I like about it. So you can still make it pretty snappy, depending on how you bias it. Again, I'm not going to go through all the values I'm going to put in here. This is just kind of showing you how the circuit's laid out. But those are kind of the things that you consider when you're actually building the amp. So generally, the appropriate way, we're going deep now, but it's also a real show now too. You guys are welcome. All right, I know this is boring, but let's take a little break for a second. Come back to me because it's all about me. It's time for Red Bull. So I like the glue under the fingers. Now, and I want you to see my cat. The value of that resistor for the plate has a pretty large effect on the feel, in conjunction with the cathode resistor, and then of course how you bypass it. So you can pretty much bypass it however you want, and it'll work the same way every time, right? But this guy here and that guy there really do make a big difference on this thing. What I can tell you is I tend to always land about 1.5K, regardless of what value I put up here. Now, in theory, if you put a 220K here, you would go with a 2.7K down there or something like that. If you go with a 330K up here, you would do like a 3K down here or something like that, a 3K1 or whatever it is, or 3.3K, whatever that value is, it's near the 3K mark, right? Or you can go with a 2.7 again, right? You could do that. This one here has a larger effect on the feel, whereas this one here has a larger effect on the kind of the actual output and drive that tube has, right? A little bit higher current drive in parallel as well. Not much though. Again, it's like a 33% increase or something like that. It's not much more. It's also got more Miller capacitance, so it does darken it up a little bit. But what's nice about that is you can use a smaller grid stopper, and that's also helpful. I don't like using grid stoppers if I don't have to, especially on the first tube stage, because that is the one. This is the one right here that puts all the noise in this circuit. Between these two, that's where all the noise comes from. So the hiss that you hear in your amp, that's generally caused by these two right here. But so the larger these values are, the more hiss you're going to have. So if you can get away with a smaller value here, obviously less hiss. So again, the noise drops. Make sense? Makes sense. So I tune this one for the feel of this circuit, and I tune this one for more of the grunt or the output. I don't honestly get much above 220K up here, and I find that 1.5K generally gives me the feel that I'm looking for, and then it's tuned to the circuit for this value right here on the bypass cap. It is not necessarily always a 25 UF. I have a couple designs where it's, I think, like a 4 UF or something like that. You have to play with what you need. Just depends. So that's where tuning kind of comes into things. So this particular design, a big part of the reason that I'm kind of going with the whole Dumble thing is it's going to have 4 gain stages. So here's 1, there's 2, there'll be 2 more, right? So let's get rolling on that next gain stage. So we'll get this guy out here. Now what I'm going to do is a dual gang volume pot. That's my plan at the moment. And you're probably like, what the heck does that mean? More or less what I mean is that I'll have 1 gain control. So we got this this gain control here. All right, so this is our primary volume control, the one that you see in all the Fenders and every other amp in the world, right? Well, we're going to have another one after this that you could consider is the ratio, all right? That's kind of akin to some of the Dumble builds, right? So let's kind of draw that out a little bit and rotate this turd around here. There we go. So I am going to put a grid stopper there. It's probably wise to put one. And I want to, no, not that. There you go. No, I had it right the first time. Dang it. Am I crazy or did it just not do it? There it goes. All right. So this needs to come down a little bit, it looks like, to stay in line with that. Close enough. And this one ended up somehow or another higher than it needed to be. No, it did not. All right. So cool. Whatever. We are going to put the grid stopper, but the grid stopper comes in from here, and I didn't need to have it that high either. Imagine that. I think this actually needs to be right there. So we're going to take this guy and move it down a little bit. Right there. And then click. Okay. And then the other side of this dual gain pot will be on the other side of this tube. Are you starting to see something yet? Is that starting to make sense what's going to happen here? Why I'm kind of calling it a Dumble-esque type of circuit. So again, we're going to put our resistor up here, and we need our cathode. I did it wrong. Sorry. We start at the bottom, and then we put our cap there. Again, I do not know if I'm going to bypass these, either of these stages. I may do it on this stage. I may not on this stage, but I leave the option available. Just FYI. So you want to try to give yourself some windage in your circuitry for that, because when you go to do your layout, if you stick your layout hard to what you've made in your schematic, your layout may miss an opportunity to put a grid stopper or a grid leak. I will tell you this, I should have already done it, and I've already kind of biffed it, but I do have, I'm going to do this. I do have a grid leak spot for this, and I already don't like that. So we're going to delete that one, and this we're going to put in, and it needs to go down. I want it in line there. That will do, pig. All right. Let's try this again. We'll get it right eventually. There we go. So it is wise to keep provisions for that kind of stuff. A lot of gain stages here. Yes, this will be a high gain amp. I'm not futzing around on this one. So just FYI, this will be the real deal. So, and I think that's where that's going to go, except for I need to come in like that. All right, close enough, whatever. So we're going to take this, do that, do this, click, there we go. And we need one more resistor still for up here. And that's close enough. I think that's, yeah, it's close enough. That'll work. And then we want to take this, copy, paste. Nailed it. I don't know how, but I did. All right. There we go. And that will be D still. So this is another tube right here. So even though it's V2 and V3, it's actually V2A, V2B. Right? Makes sense? All right. So now we just have another couple more parts to go, and we have completed yet another circuit. And I swear to God I hit it once, but it goes twice. There it goes. All right. Maybe I'm just crazy. It's probably that one. Probably that I'm crazy. All right. And we're going to go there. Why not? All right. Again, another complete circuit coming around here, going down, and we're going to go all the way over to our volume control here. Click. That guy's going to go there. This one here we need to move down so it's in line with the other ones. And this one's going to go down as well. And as you can see, it looks pretty much like a copy of the last one. Now imagine one more of these in place. And I guess we're just going to put it right there. It's good enough for me. Okay, so there you have it. And then we got one more gain stage to go, and then we get into the pie section of things. How fun is that? Now, you're probably already sitting here going, Luke, you were only going with one more gain stage, and then you got the pie. So how is that going to work out? Well, I'll kind of show you what's going on here. So this is your high watt, your typical high watt thing, all right? This is not a paralleled channel here. It just looks like it is because it just looks like it's parallel. Yeah, so it is not, but these are split and then they mix together here and then they go into this stage. Well, I'm going to keep this here and this cathode follower, which apparently you don't really need this cathode follower. You could have just ran it off of here, but they didn't. I'm going to keep it just because that's the way I'm going to keep it. But you can see I got this one, one more, and then that one. Oop, wrong one. All right, so one whole tube. Got this guy, and we're going to have one more plus the thing, right? I am not using one other tube. So I'll have an extra gain stage left is more or less what's going to happen. Keep in mind, we got 5 tubes in here in total. Okay? So let's kind of go again real quick. I'm going to try to do this a little more speedily. So bear with me here as I figure this out. Now, here's where I was talking about that other variable resistor kind of going in. It needs to go up. And yeah, no, that's good. All right. That goes up. This is going to go back a little bit. And then we need a grid leak and a grid stop. So we're going to put a grid leak and we're going to put a grid stop. And then Alt H. All right. Move that out of the way a little bit. This one will come over a little bit. And that one comes down a little bit. And I think that'll work. For now, that'll have to do. It's going to be Christmas for somebody, I tell you that. All right, so there's that. And then we need that guy. That guy. That guy. Yeah, a lot of gain stages. This thing is not going to be for the faint of heart. I swear to God. And Alt H. No, Alt V now. And then Alt H. Bastard. Sorry, this is boring. I'm boring. It's all good. We're going to get through this, you and I, all of us together here. All right, I think that is probably close enough. I will accept those terms. Let's get these things kind of in line here. Draw that up and over. Click down. I did it wrong. This is going to go over one. There it is. All right. There we go. So now we've got a whole nother circuit there. And Control C, Control V. But this is not going to be on D. This is going to be on a different one here. I have to go back to my layout. You could do it either way. You could put it on the same one as this, but you kind of run into trouble. Convert the parallel into another gain stage. No. We're already getting to a point of danger zone status, right? So we got gain 1, we got stage 1, 2, or stage 2, 3, 4. And yeah, we're going to have more than enough here. So at this point here, we've completed that circuit. So this is going to come around like that and go like that. But what do you notice? Volume control, volume control, volume control. And then we still have a master volume. Now, I did not add any other tone controls in here. There will be a high cut at least somewhere in here. And I do not know yet for sure if I'm going to put a mid cut control as well. If I do a mid cut, it'll be either in here or in here. So it'll go in between one of these two stages here. And then the high cut I'm going to put at the end. The high cut will cut all the high frequencies out towards the end. And if I need to reduce any kind of harmonic buildup before that, we can either shunt it around the plate resistor, or there's a couple different ways we can do it, right? So there's a couple different ways we can do things. So just know that. I don't know why those don't look right, but whatever. So this one I think is actually going to be off of C. I'm pretty sure it's C. I can't recall. I don't know. So now we're at what is essentially where we need to put the master volume. Except for I want the master volume on this side of the circuit. And I actually think I was going to consider... One, two, three. Okay. Yeah, that's correct. Okay. So this is our master volume, I guess you could... No. I do have it right. Yeah, anyway, whatever. I don't know for sure what I'm going to do. I have it on the layout the way I want, but I don't have the layout here with me. So in either case, you can kind of see what's going on here. So let's just move on. I'm not going to try to hash it out in real time with you guys. These are the kind of things that drive me up the wall, right? Like, how do I exactly want to do this, right? Maybe what it was that I was going to do was this tube, master volume, and then it would go into this basic driver stage right here, right? So we got two more tubes essentially. 1, 2, half of a tube. So that makes 2.5 tubes, and then 3, 4. Yeah, no, there should be 5. So yeah, maybe there is. I think I am doing it right. Whatever. I must be tired now because must be tired. Dang it! And I clicked on that again. It's weird that it shows the beginning like that. I hope that's not what you're seeing. I see it. That's not, whatever. Anyway, moving on. Let's just get the phase inverter side of things done. So you can kind of see how this goes. You just kind of basically repeat the same thing over and over again, right? Makes sense? Cool. All right, let's get a triode out there and kind of fudge in our cathode follower circuit here. So I'm going to kind of do it like they would, and then we're going to do the dual triode for the actual phase inverter here. We're going to pretend that there's another volume control here, because there would be, in theory. Flustered with myself even. Sorry. All right. So, upsy daisy, there you are. Now on this one here, we're not going to worry about a grid leak or a grid stopper or a grid leak all that much, because in theory it would be coming back in from our effects loop. So imagine the effects loop is going to get inserted into this general vicinity. So this volume control may be on this side of things. I haven't decided if I'm going to put volume control first or volume control after the effects loop. In theory, I should put one in front of it. So that way you can drive it. Now, the reason I don't like that idea is that because then the effects loop, if it is in circuit, any tonal aspects that it have, any noise that it has, it's going to amplify in here. And that to me is kind of the downer of it. So if I had it afterwards, you get a better signal to noise ratio on it, right? So you're probably not going to be running the volume at full blast most of the time. So that means any of the noise would kind of be moot or mitigated. But we're going to deal with that later once I actually figure out where I need to insert the master volume after or before the effects loop. So we're going to keep it simple in that regard. For now, we're just going to kind of bang this circuit out because we need to finish this video up. It's getting to be long in the tooth. All right. So we're going to go in to our tube, and we are going to have a plate resistor on this particular one. So let's find that guy. And, well, it also has a cathode resistor and then a plate resistor. Now this other one, now this circuit here, if you notice, gets fed from a different node, right? This one's actually getting fed from the E node, essentially. So this one is getting it from its own node, this dual triode here, but these two, the ones that we're currently working on, get their node from the E node. So we are going to replicate that, just FYI. So let's get this guy. We are not going to use a bypass cap on this particular portion of the circuit, so that's just going to go straight on down. And then this one is going to, it looks about right. That one's going to go there. And then we're going to take this. We're going to go Control C, Control V. And I think, no, it needs to go right there. And if you wouldn't mind, thank you. Now this one, remember, it's going on a different node, so we're going to put E back on that one. Not little e, uppercase E, thank you. Perfect. All right, and then if we look here, we can see that we've got a little bit of a network that goes on in here. And they did bypass that one. Well, I guess we are going to be eliminating this. All right, so much for memory, right? I'm trying to literally do it from memory. Give me a break. I'm pretty sure I asked you to flip that. Oh, Alt, not Control. Duh. All right, so sorry. This is starting to get really boring now. I'm frustrated with myself even. Believe you me, I know. I feel your pain right now, everybody. I am right there with you. But this is how it's done. This is literally how it is done. Unused half triode, something I discovered. And ground the unused pins. Huh. What was your discovery with that? That it's just a little less noise or something like that, or I've never bothered with it. I'm in debates. So what would be this tube here? In fact, I'm thinking, yeah, what would be this tube here is its own. Keep in mind, this is one tube. This is two tubes. This would be the third tube right here. I'm thinking of only using one half of it, but I may double it up and do this number here with it just to use both halves of the triode. I do not know for sure though, but as of right now, I'm just going to draw it as a single triode because that's what my intention is at the moment. But, okay, so then what we got is we need to move that over because we have a resistor and a capacitor coming out of that guy, and both of these need to rotate. And if I'm not mistaken, there's one that goes to ground. Yes, there is a grid leak there, so we need one more. Go here. All right, let's see if I can do this here. So this guy's going to go like there. That's the grid stopper. This guy goes here. And this guy went more or less like that. All right. Oh, I lost my grid. Somehow I turned my grid off. Whatever. I'm not going to worry about it that much. That looks better. All right, so this kind of comes up. It goes there. All right. So, right? Yep, that's what it does. And then it circumvents that guy. So this guy goes to here. And then this guy goes to, let's make it look a little bit better. Let's take it out like that. And then these two go to there. This guy I'm going to move over a little bit. Something like that. That makes sense. And then I think it actually went around the other side, to be honest. Yeah, it does. So this wire, I kind of biffed it. You got to double select. If you got two wires that connect, you got to double click on the one you actually want to get rid of. So this is where I was talking about, like, some of these things you got to plan ahead on what you're going to do. So in this case here, we would have to go, I'm going to get rid of this one as well. It's really difficult to add another wire in after the fact. I don't know why they did it that way. They just did, and it's angering. Oh, see how it deleted both of them? I don't know why it does that. I think it knows part of what your circuitry is that you're trying to do. So it just does it. I don't know. It's a pain in the ass. So either way. And then we can go up to that one. Then we can go into this one. There we go. And then that one went, I can't remember what side it went on. It went on the other side. So it went here. There we go. Click. All right. Does that make sense? So comes up and over. This is going in parallel with it. Goes straight to the grid. And then the plate goes up and on to the top side there. So we're going to take the plate and it's going to go straight to here. And then we need a cathode resistor. And this one's going to come up a little bit. And we're just going to, oh, you little brat, come on. There it is. All right, there's that. So now we've got this whole circuit kind of done. Same. We just come around, do that, and that, and click. All right, this goes to ground. These go to ground. Now, the reason we're kind of doing them this way is that these are each their own little star ground sort of things, or local stars, if you want to call it that. How do you explain it? There's a couple different ways that you can do all this stuff. A lot of people talk about, the star ground kind of being the litmus for how you do these. It's not that simple. And in an amp like this, where you're referencing, so let's kind of get my mouse to cooperate here. Where is my thing to get to the size? Workspace properties. Something got hit somewhere at some point, but in either case, there used to be a way to, there it is. All right, so we're going to shrink this in a little bit here. Sorry, it's getting pretty small at this point in time, but you can kind of see here that this guy is going to our E node, which is over here. So this whole circuit right here, and we're talking everything from C14 in, is being powered by this node. So where should this ground go? Should it go to the same ground as that one is going? That is a question. R29 needs to be big, correct? No, not necessarily. R29 there, I believe in here it's a 560. They've had different values for it. I've seen as high as 1 meg. I've seen another one that had some other values. There's many different variations of this particular pi section, if you will, or phase inverter section. This is a fixed bias phase inverter. So more or less, this guy right here is just being modulated by this circuit. It's being driven off of the plates over here and via this guy right here on the grid, and it wiggles up and down, and that high amount of current is driven out of this guy right here. And that's what actually drives the signal, but it's held at a semi-constant voltage, I guess, if you will. From a DC perspective, it's very stable right here. So what it does is it makes it so that the phase inverter doesn't move around in terms of its reference to its grid. So the grid always stays pretty well referenced, I guess, if you will. Whereas going the normal way, it moves around a little bit. So that's what's so nice about it. Now, you don't necessarily have to have this tube. You could have still done it off of this one. That's my understanding of how the circuit works, is you basically just treat it as if it were a cathode follower here. You still need the plate or whatever, but they used it to inject the presence control into there, and they drive it off of this guy, right? So however they did it, there's a couple different variations. It seems odd, like this never should work. My understanding and from my research on it, this is the more popular, the more favored version of the fixed bias phase inverter setup that they got. This guy right here is just another tube stage, really. I mean, if you think about it, it's just a recovery stage in essence. Imagine this being, they're not even using this triode here. It goes through a tone stack. There's not a whole lot of gain left, so this is just a gain makeup, more or less. So It's not as complicated as it seems. It's just not understood because people don't see it very often. High watt did some weird things. I'll kind of rehash at the end why I'm doing a more standard kind of power supply. I'm not a big fan of how they do. I'm not a big fan of how High Watt does his power sections. Things like this where you're referencing to a earlier node is a little odd to me, but I think the reason that they did that is in order to make it so they're not slamming the ever-living crap out of this guy, right? Over here, there's less voltage than there would be here. So if this were on the same node, it would have basically the same voltage potential as this one, more or less. And I think he found that it just was quieter over here because its feed is off of a quieter node, right? So this is less hum, less noise to inject into this guy. And then, of course, being at a lower voltage, it doesn't overdrive this stage needlessly, and it stays cleaner longer, right? It's kind of a hi-fi thing, I guess, if you will. But all right, so we got that, and then we go into what's more or less a standard Pi. I don't think we need to go any further because this guy here has kind of already finished the job for us. Where are we at right now? We're at an hour and 13 minutes, so I'm kind of almost just... I think you guys kind of get the idea, right? I'm shocked that there's still 9 of you in here listening to me go through this crap right now. This is painful. I told you this is not going to be a fun series. This will be not for the faint of heart. Mainly because I'm going to do it all live, and I'm going to do it as much as I can on camera. So this kind of stuff here is not going to be typical after we get past this stage. It's going to be more this bench shot that we have here. You'll get to watch me drill holes into a metal cabinet. You saw the chassis earlier. You'll get to see me stuff all the components in it and start building the amp, right? So do be mindful. Well, I'm glad you guys are stuck to the screen. But do be mindful. This will be kind of a painful for some of you, maybe not so much, but others, they're going to be wondering what the hell is wrong with me. I already wonder what the hell is wrong with me. All right, so anyway, let's kind of get back into this. Maybe what I'll do on the next episode that I do is I'll kind of show you a more completed version of this. For now, you kind of get the idea. The output section is going to look just like this, right? We're going to add in this part of the circuit there. No. So let's just kind of solidify a few things as to why I did what I did and where, etc., etc. Why am I going with so many gain stages? I wanted to do a high gain amp. I have never done one yet. This will be the highest gain amp I've ever done. That's part one. Part B is I needed a challenge. Everybody goes on and on and on and on and on about how the high watts are like the creme de la creme when it comes to pedal platform amps. And I'm using my quotation fingers, right? Well, if they're so pedal platform friendly, then why the hell didn't they just build the preamp into the front end of them, right? They don't tend to have effects loops in them, right? There are some now, and they have been retrofitted into them, but there's not many of the old, or none of the old ones that had an effects loop that I know of, the originals. Topographically or topologically, however you want to say that term, in later versions, they used this other half of the triode, and they basically churned it into a cathode follower to drive the tone stack. That's all they did. All they did was put this guy back in the circuit and run it like a cathode follower, which more or less made this thing a plexi. It was just a plexi that went into the high watt output section. Make sense? That's what they did. In this case here, I'm going to use this as the return point for the effects loop. So this will basically be the recovery for the effects loop. So that's what I was saying is my big debate on whether or not I should drive all the voltage from the preamp into the effects loop and, you know, tame it down from there and then use this as a recovery, put the master volume after it, or if I'm going to have to put the master volume in front of the effects loop to keep it from overdriving or whatever the heck we need to do. That I have to figure out. I do not know yet. As far as things go, the reason I said this is a dumble is a lot of people don't really know this, but when you really get down to the brass tacks of what a dumble is doing, they are just putting a volume control in between each stage. And that's all I'm doing here as well. I'm just putting a volume control between each stage. So this one here, standard volume control, one single gang. This one and this one are ganged together. So this tube right here is circumvented by 2 volume controls. Call it a ratio, whatever you want to call it. All right. I may have been wrong about, no, that's right. That's the master volume there. Okay. So you kind of get what's going on here. With that being the master control, when you turn these ones all the way up, it basically cascades the remaining parts of the amp. Riley, please do. And I have since learned that the chat that I'm seeing on my little thing here is a little bit further behind than if I actually go over to here. If you go to this one, it's a little more realistic in terms of time, but get on with it, Riley. But while I'm waiting for you to make that response, I'll just kind of finish up my thought on that. So yeah, the idea behind that, and I've had great luck with this in some of my other designs, is that when you circumvent the volume like that, it's kind of like an orange. Orange does it a lot in some of their designs. But it's great because when you dial these both back, you now have basically brought the remainder of the amp kind of into calm zone, right? It's not overdriven. It's just flowing signal through really nicely. So this guy isn't being overdriven. This guy isn't being overdriven. And then you still got another volume control, right? When heating the preamp, I used a separate heater supply. So there is some debate on that. And it really, I think it comes more down to layout when you start having problems like that. Space is your friend, and just a very clean and clever layout. Objectively, and I'll kind of, maybe we'll go, we'll kind of look at some of the high watts and we can pick it apart a little bit. Now, there's people going to argue that, it's obviously the best thing since sliced bread, but there are some things about them that are not that great. But where these tubes are placed is probably a little more important than, some of the other things. This tube here will be in a different spot than all of these, so I will have to run a heater line that goes out to the edge of the chassis, over and around and into this. But this guy will be very well isolated from the remainder of them. The remainder of the tubes will be in the center of the amp, so there'll be 4 tubes in the middle. So we'll have the phase inverter itself, its driver, and then these 2 tubes here. And I say 2 tubes because this one here is part of another tube. So you can use the 12-volt heaters, and what they're actually doing is probably a 12-volt DC heaters. DC is technically quieter, but where you run into challenges is that you now have to have another power supply specifically to them. Now, most, and I say most, not all, but most power transformers that you can buy on the open market don't come with a 12-volt transformer built into, a wind built into it. That means you have to put another transformer in the amp or find some other way to come up with a 12-volt driver. And if you saw the Cerberus last night, you may have noticed that module, that power module I put in there. Let's come out of here. I think we're done with this portion of it. But the power module that I had over here had a 5-volt and a 12-volt output for it. And the 12-volt was rated for not enough amperage to run probably 5 tubes, but probably enough to run several tubes. I think it was rated for 5 amps. No, it couldn't have been. Maybe it was 5 amps on the 12-volt. I don't know. I'd have to double check. Let me double check. Since I'm close enough here now, I can kind of just, it won't take long. Hold on. Yes, you. 8 amps. I'll be damned. Okay, I didn't realize it was that beefy. I bought a pretty gnarly unit. The 12-volt output on that module that I bought was an 8 amp output. And the 5-volt driver that I'm using for the relays was a 1 amp. So that's actually pretty impressive. Now, I would not actually expect it to do that in reality. AC heaters, and it was completely fine. Yeah, I can believe it's better. Technically speaking, AC is the noisiest because it swings below 0, right? You know, it inducts more noise into the heaters. That's 96 watts? No, that's not 96 watts. Well, 8 amps. Okay, I get where you're coming up with 96 watts, but it's pretty beefy. I see where you're getting the numbers from now. Sorry, I didn't mean to doubt you that immediately. It was superfluous for the job. That is a fact. I just didn't want to deal with it anymore because, as I mentioned, where the fudge are you? I know Andy was kind of giving me crap today. Let's get the other guys here. So this is my box of trash, right? So this is an optical board or a solid state one. This one didn't work at all. And then this is an optical one, more or less like a Vactrol, but this one didn't work at all either. This one was too noisy as well. So I had to design my own. But these guys here, Andy's admittedly said that he has had trouble with them before where they get stuck or something like that. Or for whatever reason, they'll click one way but not the other way. My thing with them is that I didn't like that you had to solder directly to them. That was one problem that was just whatever. Horrible noisy layouts. To me it's about layout. I don't ever have a hum problem. But maybe I don't know. But then again, I haven't done a whole lot of high gain amps either, so I'm not going to be too prone to that. It's mostly going to come down to layout and space. Like if you're trying to stuff 5 tubes literally right next to each other, it's going to be a hell of a mess. If you can build space, then space is your friend. But great layouts is where it starts. Clever layouts definitely, are smart. Keeping anything not running parallel, if you can, is ideal. You want things, if they're going to crissy-cross, you want them to be, least amount of cross-sectional area as possible. And then not only that, but space. So even if they are crossing each other, they've got space going in the other direction. So this guy here, I don't know what it was. I had a solid 6.2 volts or whatever it was. It was just under 6.3 volts on my heater. Now, the heaters were referenced to a 70 volt, elevated point, right? So I did elevate the heaters. But all that means is that the ground reference for this was just elevated by 70 volts. So it was still 6.3 volts measured across the leads right here, right? The input side of it. It was 70 volts above ground or true ground. That's a problem though with these things because if you're going to do something like that, you definitely cannot reference this thing to ground or it will blow the thing up, right? You cannot connect these things to ground. That other one I have, I can reference it. I referenced it to ground. So the 5 volt tap that came out of that one, I have it going to ground. Makes sense? So that's what helped make that one quieter because it could tolerate that kind of stuff, whereas this one will not. This one, I was only getting like 4.8 volts out of the 5 volt thing, and I think it was just not quite enough voltage to get these things to snap. One of them would always work. The other one, not always. Like, I could always get one half to work fine, but the other half didn't work enough. So trying to drive 2 of these, for whatever reason, it just wasn't enough to get these things to clack over. And I know that Andy likes these Bourne's pots. I don't like the feel of them. I just don't like the feel of the pots. They're rough. They're not very precise feeling. And then in these instances here, these ones just lost their reference. One of them wouldn't turn off all the way, so it would never go quite to 0. To me, that is a big deal. I know most people don't run them all the way down, but when I turn a pot off, if I turn it down to 0, I expect nothing to come out, period. The other one, it was a little different of a problem. I think it was that the ground side actually lifted out of circuit, so it didn't actually work as a volume pot at all anymore. I don't know if it was from me futzing around too much in there or what, but both of them failed, and they failed at different sections in the amp. and so I just replaced all 4 of them. So whatever, ain't no thing but a chicken wing. It's just a pot after all. I've had Borns in like my guitars and stuff. It's hit or miss with me. They're nice pots. There's nothing wrong with them. They do what they're supposed to do. So if you like the feel, then, whatever. If you don't like the feel like me, then, I just don't use them. I did have to take this guy out. This was in there. There was nothing wrong with it. I'm not a huge fan of orange drops anyway, but I needed the space. So that other board that I put in there was sitting over the top of that guy, and I didn't want to move it over to the other side because it would have made all my runs just that much longer. I don't know. If you watch the video from last night, you get what I mean, but those wires would have had to been that much longer, that much closer to all the noise. So I made it so that my board literally got right up to the phase inverter, and this guy was too tall, and this would have stuffed out the top of the amplifier, which means I wouldn't be able to put it in the thing. So that's the only reason I had to change that one. Nothing wrong with it, though. I'm not a fan of them, though, so whatever. I put the good stuff in there. All right. Any other questions? So yeah, my next one is why so many volume pots? Okay. So you're talking about this build, the giveaway build. Again, kind of going back to the Dumble thing. If you really look closely at his circuit, he's got a trimmer pot on one of the last stages. So he's got the primary volume control that's after the tone stack that's built in. Let's go to the other screen here. It makes it a little bit easier to explain it. So you got your input here on a Dumble. He's got his tone stack, and then he's got the volume control coming out of the tone stack. It goes into the next stage, and then it goes, I believe, into, I don't know if it's this one he's got a trimmer on or if it's a different one that he uses a trimmer. Maybe it's on the other one, but in one of the 2 spots, he's got a trim, and then he's got a ratio. The ratio is like a drive knob that goes on the last stage before it heads out into the remainder of the amp, right? That's where the effects loop is and the master volume, etc. Right, so he's got 4 total gain stages. 1, 2, 3, 4. And then the recovery from the, I think he doesn't actually even use a recover. I'm pretty sure he goes straight into the phase inverter. And there's nothing special about the phase inverter. It is simply a Fender-style phase inverter. So take these guys out of the equation here. That's all he's done is put a trim knob on this guy and a ratio, what he called it a ratio, which is basically just another drive knob. All right, so this one is fixed. So it kind of sits where you want it to be. And then this one you just add to your heart's content. Now what I'm going to do to circumvent that issue is with a dual gain pot, essentially you can put a resistor over the top of one of them, and the taper won't be right, but the gain range that it has will still be the same. So you can kind of make it work the way you want. And then again, I got grid leaks too. So between the grid leaks and the pot value, I do not know what pot value I'm going to go with. I can tune how much drive total goes into this one, and I can tune how much drive total goes into this one. So that's all I can say. Now, going on to this giveaway side of things. So now let's talk about this actual giveaway. We're going to come out of this because we don't need to see this anymore. John probably did not appreciate how difficult this last giveaway was. Despite all the problems, Riley, you're here, so this is great. Now, I do feel for you, Riley. It is rather unfortunate that it got that far before things were found out about Linus. However, I think what we can say about that is that you're not missing out. There's always good things to come to those that wait, and it can always get better. So yes, you missed out on an opportunity, and you did give it up to someone else. And I appreciate that. It does not go overlooked. That does not mean that all your opportunities are spent. It now means that more opportunities are probably going to come your way, in fact. So it's just one of those things. I could not foresee all the potential pitfalls I was going to have. And once they started coming along, it was just like, well, how do I deal with this? And the one takeaway, the one thing I learned about the last giveaway is that you cannot, I shit you not, you cannot make anybody or everybody happy. It's a giveaway. Like, how much simpler can it possibly be? You're not investing anything in it, maybe a little bit of your time. I mean, that was the idea behind that last one, is take your time. But like, I'm giving something to you. So how hard is it to give me a couple hours of your life, right? It's like a timeshare, right? Except for the possibility of owning the thing at the end is good. And in that case, there were only 35 entries, 35 individual people. So again, I learned that it was not easy to give an amp away. And you know what? He did everything right. He had it prepared for when I got there. He spent money on the transformer that he needed. He spent money on a cab, right? Exactly. And Zab, I tell you what, man, it is not easy. And John's even starting to find out. You create the simplest rules ever, and you still get people that bitch and moan about how it can be fair this way or how it can not be fair that way, or add nauseum to it, whatever. Sure, you can make an amp head to a combo. I actually have kind of done one that way. I have a 5-watt amp that I built. I don't know if you've ever seen like the Matchless Avalon or whatever it is. I believe it's the Avalon. That one's kind of basically a head that's in a combo format. And Linus, yeah, I mean, he totally deserved it. He won. That's all there is to it. So this one, I kind of wanted to let John realize some of the pain I went through, and it's not going to go unrewarded. So John, just don't think I'm sitting here hiring you or employing you to do stuff. You are earning your way towards something. We don't know what, but you're earning a passage, if you will. So don't cheat. Don't cheap out. Just keep playing the game. So I did put the rules in the description. The rules are very simple. If you want to enter this little contest, and it's not even a contest, it's just if you want an opportunity to win this amp that we're talking about today, simply create a short video. It does not have to be long. We don't need to know your life story. We don't even need to know much about you. We just want to know you as a person. Introduce yourself so we can see who you actually are. And a quick little rundown of your rig. Hey, I've got a PV triple X, and I've got a dinky little, cheapo 2x12 cab, and I run out of a Legator freaking, guitar that I picked up secondhand from the store, whatever. And then this is my cheap little pedal board here that I use. All right, that's all we want to know. This is just something. We just want to see that you are willing to put in that much effort, right? And that you have an interest in the amp, right? That's it. And it's just kind of a way for us to vet and really get people that want the stuff to show up, right? Well, and I would say really need to go to the people that need it is one thing, and I'm super in that kind of idea. Obviously, somebody that's got a full-on studio with every amp known to man probably doesn't really need that amp, but I can tell you right now that somebody that's already that well established is probably not really interested in me anyway. I'm not that famous yet. So this amp, if I had to put a value on it, honestly, I would say it's probably in the 10 grand mark. As far as what I'm actually going to give you and put into it, yes. Custom, I mean, it's fully custom. There's never going to be, well, I'm not saying never. Right now, there is not another amp out there like this one will be. This is at the moment, a one of one. I do not know if this will go into production for me or not. We will find that out. But essentially, when this comes out, it'll be one of one. Hand built, as you can kind of see, all the way in, through and out. I will be drilling every hole in the chassis, with the exception of one. I paid somebody to put the little square hole in the back. But, I will hand mount everything, yada, 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 et cetera, et cetera. The cabinetry, Vinny, is it Vinny? I can't tell. I know it looks like Vinny from what I can see, but I do custom cabinetry, and if you've seen some of my other videos, right, it kind of shows what I'm about. I don't really. Let's see here. Let's just go to this other camera view here, because why not? So, take this with me. You can see that guy right there. That's one of the cabinets I built. You see this cabinet right here? This is one of the cabinets I built. So as you can see, I try to show the guts, which is pretty rare. Most amps don't do that. And most amps don't do this kind of thing here either, where lights kind of come on and you can see lighting, right? Most don't do that. So mine are very bespoke in that regard. So yeah, hand built, in, through, and out. No corners cut. So the parts, I'll just leave it like this. What the hell? May as well. This looks funny anyway, just seeing my hands. Parts wise, the transformers alone in this amp right now are a little over $400. The chassis is another $100. So, I've been lucky in terms of the pots, but thank you, sir. I appreciate that. So yeah, I mean, what are we, we're $500 right there, and we haven't even hit, anything else inside of the amp. The caps that I'm using are they average out probably $5 to $6 a piece. And then all the resistors I use are $1 a piece. So after shipping and all the other fun stuff, it works out to about $1 a piece. So small parts all in, cabinetry wise all in, I'd say we're well into near the $2,000 mark all in on parts after everything's all said and done. Time, don't even get me started on the time. The last build that I did, the last giveaway that I did, was over 200 hours. I stopped counting after 200. So you can't even make the time up on that matter in terms of value. So that's why. I've never had problems with the dual gang pots. I've heard of it being an issue before with some of some, but I don't think it's going to be a problem for me. But we'll see. Now, as far as the value that we placed on this particular amp, we had to give it a value, right? So we put $5,000 or $6,000 as a value. Real world, I mean, obviously nobody's going to pay me for all my time. So if it took me 300 hours to build this thing, do the math on that. Let's see if I even have the calculator up still. I'm not really good at the math. But if I spent 300 hours on this thing at, let's just say $25 an hour, that's $7,500 just in labor, right? That's at $25 an hour. I live in California, bro. 25 ain't gonna cut it. So again, let's just give it a raw $200. I mean, we're not saving all that much at that point. So times $25 an hour, that's still $5,000 just in labor, just in time. These do not go quick. So that's another part of the idea behind this build series, is to try to garner interest in and build an appreciation for this craft that we're talking about today, because it's not easy. No, I do not do solid state amps, mainly because, I mean, all the other companies out there do solid state. I'm not trying to win on that game. Tube amps, there's still a market there, and there's still something to be won. There's still different things that can get done. The market's still strong, I think. So, yeah. CTS are like 6.3. I don't like CTS for amps. That is me. I'm not saying they're bad, but the CTS for me has just been... Hold on, let me do this here. We're going to go that way. There we go. A little more normal now. I'm getting distracted looking at my fingers. The CTS pots, to me, the thing I don't like about them is when you get down to like 0. So when you turn them all the way down, there's like this window where it does nothing. So eke it open a little bit, it doesn't do anything, and then all of a sudden it's got more than you wanted. So it's like really touchy if you're really trying to get like finite low level stuff going on. These Borns in the Cerberus here, not that problematic in that regard, when they, reference to ground completely anyway. So yeah, they were fine and they worked the way you'd think they would. I just don't like the feel for the most part. That's my only major gripe about Born's pots, is the feel. Alpha. I think alpha pots are the end all be all for amplifiers. In terms of the feel, it's got a nice, solid, firm feel. So you have to actually grab the pot, and it doesn't have like this window at the, the bottom edge where it's just nothing and then everything. So they're just really smooth tapers. Probably not. I don't know. Maybe my luck has been a little bit different. Now, I will say that I've measured a few of the alpha pots I get. And no, they don't measure exactly, if it's a 1 meg pot, it doesn't exactly measure 1 meg. Maybe it's 980 or 900 or 940 or whatever it might be. I've had one that came in a little over a meg once, but it's usually not over. I'm not going to freaking sit there and hum and haw over, a K maybe. Yeah, maybe a K if I'm going with a 1 meg. Now, if I got a 500 K pot and I'm getting 450 K, I'm probably not going to be super stoked about it, but it's not the end of the world. We do have grid leaks. We do have grid stoppers. So does it, I guess, if you were going to sit there and you were going to measure every single pot and you had to have that value for every single amp that you built with that topology. Yeah, no, I understand that, but it's the same for all the other pots too. But if you were to sit there and actually do that, you would probably only keep 10% of the pots that you purchased. What are you going to do with the other, 80, 90% or whatever? Here's the other thing though. How do you know that you don't like the result of a 940K pot, right? As opposed to 1 meg? Or how do you know that you don't like a 480K pot as opposed to 500K, right? You don't know until you put it in there and you hear it. If your thing is, I'm putting a 500K in there and that's what it's going to be every time, that's what your litmus is at that point. You don't know if you don't like it because you've never done anything else. So I kind of treat every amp as its own little entity, if you will. So yeah, if I've got 3 or 4, I've built 4 or 5, of my 18 watt designs, and each one's just a little bit different. But I've done something a little bit different in each of them anyway. I just experimenting, 3 of them are more or less prototypes, and then the other 2 are out in the world, right? And I got another one to build right now, actually. So none of them have ever sounded bad. There's not one where I can say this is definitively the one that is the one I'm going to base all the others off of. They just kind of have their own little character about them. And it still sounds like the amp. It still does what that amp does, but I just haven't had that much of a problem, I guess. But then again, it's not like I've built 100 amps yet. Like, I've got, 10 or 12? A little over 10 that I've gotten in designs and built out there. So not a whole lot in the grand scheme of things, but you guys just don't know about it because I don't show them every single one of them to you. So there's a lot of R&D going on in the background that you guys don't see. That's all. And then for dual pots, again, I'm not that worried. So the beautiful thing about a dual gain pot, let's say one is lower than the other. All you do is just flip the leads around. If you want the other pot to be a little lower anyway, there's no rule as to which one you put first. So if you want the lower side to drive the higher side, you can do that too. Metal track. Okay. Yeah, carbons are noisier. I don't know. You must build some like super high gain stuff, man, because I know that you did like your little slow build. What did you end up having to do to kind of keep that one under control? Because that one, I mean, essentially has four or five gain stages in it, right? Riley, is that correct? Am I correct in that assumption? It still always comes down to layout. Like realistically, it comes down to layout. Oh, that's what we were gonna do. Hold on, let me go to a thing here. Not highway, high watt. Let's do gut shots. Excuse me, real show. Okay, so let's open in new tab. Yeah, it's not a real one, but this will be close enough. Yeah, yeah, right. I don't like using shielded cable if I don't have to, but sometimes you just have to. All right, so let's go over to here. All right, let's talk about why there's some pitfalls to how these things work. Okay, I don't like cap cans. All right, I don't like cap cans because they take up a lot of space, and you can see what he's got going on here. What do you got going on here? You got 1, 2, 3, 4, 5 of these huge, ginormous freaking things eating up space inside of your amp. And what you'll notice is that he's paralleling or series wiring some of these together. With the exception of this one here. This one's got a slightly different thing going on. But these two are ran in parallel. This one is partially ran in parallel. And this one is ran in, or I say parallel, I meant series. Ran in series, ran partially in series, and ran in, I believe this one is, there's two separate nodes here, and he uses each one of those for the something on here. So that one doesn't count. That one's ran more or less normal. Now, what sucks about cap cans is on ones like this where there's 3 things and ones like this where there are 3 things, that ground is shared. Okay? So if you remember, we were talking about over here where this is circuit A and this little thing here is circuit B, right? So technically speaking, if this one and this one are on a different node, that means that they should be grounded to a different point, right? Their power supplies are coming from 2 different places. There's 2 different references to ground. Well, in a cap can, you don't get that luxury of having 2 different grounding points, right? You're taking both of those power supplies and grounding them to a single point, which can be problematic for noise. Other things that I don't really care for in the high watt design, where if it's problematic or not is up for debate, but you've got these heaters right here. This heater runs right next to this board right here. Ideally, I would probably want these to be a little bit further away. The cable length is great because it's nice and short. Oh, yes, we are. BC, good to see you again, man. Right, so you've got to pick your poisons or pick your battles, right? In this case here, he's using heater wires pretty much near a bunch of other components. But the leads and runs to the tube sockets themselves, pretty short. Not the end of the world. I like going up and over as opposed to down and in for my stuff. I don't find a problem for the heaters. They shoot like fireworks, right? That is one way to look at it. I've only had one of these fail on me, and it wasn't in that glorious fashion, but I just don't like them because of that reason. Now, the reason that they're running these things in series like this is because he's got over 500 volts in this thing, and these caps are only rated for 500 volts. So the only way to get the voltage where you need them is to run them in series, which means if this is a 200 UF and that one's a 200 UF, you're actually only getting 100 UF worth of capacitance between them at, 1,000 volts or whatever the voltage was for these two together add up to be. So if these are both 450 volt caps, they would be, 900 volts. You get what I mean? So you add in an expense to get less capacitance and all for what? Voltage? I don't know. I'm not a fan of voltage. Voltage is not the end of it's not the way to win the race. you can still get the wattage you want with lower voltage that's under 500 volts. You can. I'm not saying it's easy. I'm just saying you can. So that's it. That, and then the grounding, right? The grounding is kind of a bummer because, obviously. So yeah, you got all this kind of noisy stuff around a bunch of components. Now, another thing I don't really care for with the high watts is everything is linear, right? Everything's running basically parallel to themselves. They got a couple little things done up cleverly here. That means there's a lot of wires jumping back and forth underneath there, right? Because something has to connect elsewhere. And if you know me, I like making it so that all the bad stuff, all the stuff you don't want, sticks on one side of the board, and all the clean stuff, the ground side of things, sticks on the other side of the board. I have a rule basically where my HT runs do not breach the middle of my board. I like using slightly bigger boards as well, but objectively, I would want to move these into the amp a little deeper, and I would be okay with running slightly longer wires that come up and over. Now, another thing that's a plus about running the wires up and over is this amp is getting turned the other direction, right? So this is basically the bottom of the amp, which is really nice because it's right next to what should be a nice aluminum plate that acts as a shield. So what difference does it make if you run the wires really close down here against this shield or up in the air a little bit more close to yet another shield, right? That kind of thing. So the mentality shifts a little bit depending on how you want to look at it, but that is just a me thing. But yeah, things like this where you're taking HT and running them along, your pots and stuff like that, and all these other wires here, not my idea of fun. Let's see if there's another one that we can kind of glean. This one is like a popular one here. And again, I'm not bashing on high watt. I'm just saying that just from my mindset and my idea of how things could be a little bit better versus, other realities. So again, you can see a bunch of caps. This one's been replaced at some point in time. It looks clean, obviously. It's all kind of done up. The lacing is really cool. Everything, all the noisy stuff is along the outside edge and down and around. That's great. That's smart. It's clever. This one is cool because he did, instead of running them up the middle, he ran them again towards the inside and away. That is better. I like that. I prefer that. But over here, he's got this guy, and it's running, right down the middle of everything there. To me, that just makes no sense. So I rather try to get it so that things come off the top. All the noise stays down here at the bottom. These wires are shielded anyway by the shielding that goes up on the top there. And then this guy, I would rather see kind of back a little bit further and finding a way to get the power, the HT, to stay as far away from the front side of the amp as we can. If you look over here, you can see that's the input right there. So you've got this noisy source of stuff right here, right next to the inputs. Not my idea of cool. So, and you can see here, this is the shielded wire that they're using for the input right next to this thing. Objectively, that's not my idea of how to do it. Now, as far as all this other stuff over here goes, I don't mind this at all. This looks great. It makes sense. Like, this is how you kind of have to do it, to be honest. So, I'm cool with how this is all done here. But I'm just saying, like, I would rather this guy get moved down and back over here, and then that, you see this guy right here? That's the other umbilical that fires off half of this stuff anyway. So why not include this down here and just run it in there with that umbilical? Q mark. I don't know. Is there another one that maybe makes sense to look at? I don't know. That's someone else's build. What is this one? We got off the images somehow. I think this is like one of the more popular ones again. Yeah, we'll open it up. Why not? So, again, it's kind of similar layout. There's this big old cap can sitting there right next to the inputs. Everything else is great. I love this. Like, that's great. Again, he ran the heaters along the outer edge. I like that. That's fine. It especially helps because all the other lines are going away from it and, along the chassis. That's great too. Along the chassis is great. Monday morning. Okay. Yeah. Hell yeah. I'm glad you guys are interacting, by the way. So, just those little things. It's not bad. It's obviously like there's no arguing the popularity and, you know, the greatness of what a high watt is. When I first saw them too, I was like, that is how I want to do my amps. And then you just kind of find other ways to do things. And being that my builds don't tend to have issues with noise, even using a what would you call it? So I have another driver inside of my amps. We can come out of this view. So when I say driver, I have an LED driver that I have to put in the amp. And it runs off of 120 volts. So even with another power supply inside of the amp that is known to be noisy in some instances, I don't tend to have problems with noise. So I kind of pride myself in having clean builds. Based on the layout that I got going on so far, again, I don't have it to show for you guys. Well, maybe I can get it for you. Ooh, it's not the completed one. It is A1. I started it, and then this is where I left it, I believe. Let's see what the recent show. Did I get it? Yeah, there it is. Do I have... I don't know if I have the software I need on here, though. Give me just a second while I... Oh, I do. All right. Hold on just a sec here while we do a thing. I'm going to make it. I'm not going to bother with that right now. Okay. File. Open. Oh, I know what I need to do. Hold on. Sorry. I'm almost there. What the hell did I do? Sorry. We're working this out. I need to download something here. And hopefully it's not pissing other things off. I think we're going to be all right. All right, there we go. You over here. Thank you. We're almost there. Oh my gosh, really? It's going to make me work. Please. Oh my God. It's going to make me freaking work, I tell you. There we go. Jesus. All right, here we are. Yeah. All right, so let me shrink this down so you can actually see it, and you'll kind of get an idea of what my tentative at the time. This is not the most recent version of it, but you're kind of getting a sneak peek, if you will, of where we're going to go with this thing. All right. So, what you're seeing here is my tentative layout. Makes sense? So this is the power transformer over here, where all the power stuff is. This is the input over here. What do you notice is not over here? Anything noisy. All right. So nothing noisy is over here. This is kind of living in its own little world. But this transformer here, the output transformer, everything that it's going to have is going to run in this direction over here. Make sense? This is tentative. This is not complete. I have made other changes since this version that you see here. You can even see I left some turrets up there. But this is the input, and this is the last stage here. So this is the phase inverter right there. So this is the HT. Again, HT comes in all the way from the ass end. It's far and away from all this crap over here. All these leads here come off and fall in, right? The only thing I'm not showing here is the heaters, but the heaters will come around from this side over here, and it'll shoot down this direction, and then it'll come out to the edge of the chassis, up, over, and then in and shoot in. And you can see there how I did my parallel no cap, as the kids say. Right? So I got my parallel triode over here, right? So this guy is off in its own little world. And you can see here, this is that unused half that I was talking about. I may do this. I don't know that I will, but I may. And then you can see how I localize the caps for each of their stages. So this is the noisy, bad, nasty stuff here. It's over here. It takes care of all that crap, keeps it over here where, guess what? The exit of the amp is at, right? This is where the safety ground goes. That is the spot where all the noise wants to head towards, in theory. I mean, that's not technically how it actually works, but that's the idea behind it. So the noisiest stuff is right near the exit of the amp, and it gets nothing but cleaner and cleaner and cleaner and cleaner as you get closer to the input. I didn't really want to put these here. I would have preferred to put them a little further away, but being stuffed in the middle of the transformer isn't as ideal as I would like it to be, but this is just tentative. Right now, this is what we're going to go with. You can see here what I did with my diode string. This is going to be the bias supply right in there. There are a couple little jumpers here. This is the circuit for the negative feedback. So it kind of jumps around and over and then up into the feedback loop over in here, the NFB. So everything kind of stays away from itself. It's just a little messy right in here because I do have some wires that need to jump over. Now, there was another plan I thought about that I could do, and that was to take these guys here and put them on this board so I don't have to go over to here and then jump back down over to here. Still going to have wires that would come over, in essence, and this guy would still have to be up there, so I'd still have to run this wire across, but that was one of my ideas for cleaning it up. I don't know that I'm going to do that, though. And then the effects loop ideally would sit in here somewhere. Again, I don't know space-wise how I'm going to work that out yet. So I think the effects loop is a little bit deeper than this space is. So I might have to either lower this down a little bit so it's closer to the chassis, or raise it up more to give clearance so that the backside of the effects loop can fit in here somehow. Right? Crazy putting that little guy up in the corner on its own. But think about that, though. Like, how short is that run? Like, that is probably literally an inch long run, maybe an inch and a half for this one. This is the ground. This one doesn't show the grounding scheme that I have for this yet. This is not done. So this guy will get grounded over here, so I will ground at the input. So this whole node right here is grounded right at the input, like it's supposed to be. Ideally, that's the better way to do it. And then the remainder of them will get grounded back over here. And then, of course, there'll be another node or another ground lug. I think I might put it down in here for the power section. And then, of course, the safety one would be over here. So all the cleanest stuff that you want to stay clean, all on its own, out in its own little land. Makes sense? Furthest away from here. That's the starting point. So that's what I'm talking about with layout is king when it comes to making a clean noise-free amp. All these runs fall in line with each other too. But you'll notice here, that's my HT. That's my HT. This is an HT right here. It does not breach the middle of my board. Everything on this half of the board over here is lower voltage or ground. Anything else over here is all high voltage stuff. Right? So this is actually a dropper right here. So this dropper feeds this node right there that feeds those 3 triodes, right? Makes sense? So all the HT stuff stays over here. Now, you're probably sitting there going, but Luke, it's running right next to all these guys. These are on turrets. So this wire, even though I show it like this, it can come up a little bit and go over and then down, right? It doesn't have to lay near these turrets. These turrets are what? At least a couple, quarter of an inch maybe tall. So I think it's every 1/8 of an inch you lose 3 dB worth of noise or something like that. So we're going to have this wire that's under a G10 board. So it's separated by the width of the G10 board and another quarter of an inch of turrets. And these are sitting on the top of the turret. So again, plenty of space in that regard. These wires that come off the ends are coming right off the ends and shooting to exactly where they need. And all of these runs are very short. Does that make sense? And even in this little galley right here, even if I did shoot it straight across, again, it's coming off the top of the turret and bouncing down. So again, we've got over a quarter of an inch of clearance on all of those wires. It's all just about being crafty about where you put it. The tighter your amp is, the smaller the space that you have to work with, obviously the more difficult it gets to get everything to lay out. This is a tentative one. I have another version of this that is much, much better and actually shows some of the grounding being done as well. So this would be my low cut. This would be my first volume control. This would be my dual gang volume control. This would be my master volume, I think, and then I might have added, treble. This would be the treble. So this would be the dual gang, the treble, and this would be the master and the presence. I may need to put one more in here for a middle control. Don't know for sure if I'm going to do that yet. So I'm going to probably try to make it so these are a little bit tighter so I can get one more pot in here. And then we probably still got to find a place to put the name. Like this little area right here is not going to be enough space to put a name. Start thinking of a name. We haven't put the poll together yet, but start thinking of a name for this thing. Dumbwatt is probably not a good name. So we are 2 hours and 7 minutes into this. I'm going to back out of this here. We're going to go to the camera view here. I think we kind of beat this to a dead horse. I'm shocked that there's 13 of you right now in here actually watching me do this. That's kind of blowing my mind right now, to be honest. But I want to thank you guys for coming in and hanging out with me. Is there any questions? Did we really kind of nail down what we're going to do with this giveaway amp? Do you have a good idea of what it is you're going to receive? I think you can kind of see where we're going with it. Does it make sense? Any questions? If not, I think we might call it for today. So this is the official start, if you will, of the giveaway build series. This will be the first video in that series. So I guess you can call it the official announcement of it. John of Team YDNA fame, of Team ATech fame, and of Internet Money fame is going to manage the giveaway portion of this thing. So the email address that you need to send your entrance exam into, we'll call it entrance exam, is in the description, and the rules are in the description. The rules as an entrant into the giveaway is pretty simple. You do need to be subscribed to this channel. You also need to be subscribed to Team YDNA and or Team ATech. The only reason I'm kind of pushing the Team ATech is I'm ATech here, so he's got a Team ATech account. Kind of makes sense that you could do all three if you would. That would be great. But at least 2 of those are required. This channel here and Team YDNA are requirements. If you go to Team ATech too, that's great. Hopefully he'll start posting content there. That's part 1. So you do need to send just a little introduction video to him. Hi, my name is Luke. I'm a cool ass dude. Check out my guitar rig. I got this badass Cerberus over here, and I want to win this amp. That's it. That's really all you got to do. Just give us a quick little, hey, here I am, rundown of what you got, and call it a day. Zab, thank you so much. Come on in. Or take care. We'll see you on the next one, but keep coming on in. Okay, so that takes care of part 1. Part 2 of your requirements as an entrant is that on the day of the giveaway, you must be present during the live stream. I know that sounds painful, but you must be present to win. You have to want to win the amp, right? That was not my rule initially. That is actually John's idea. So it will be very clearly and evident. You're going to have plenty of lead up into this giveaway date and the times. We're going to try to make it fair for everybody. He's in South Korea, and we're in the Americas. In the Americas, we got at least a 3-hour time difference. I don't know about other people in Europe and all that fun stuff, but if you want to win the amp, you'll be up at 1 in the morning to make sure, right? Thank you very much, Riley. I appreciate that. Later, my man. Darren Noon. Oh, hey, what's going on, man? So there's that. So that's the second part. You do have to be in attendance. Another thing that you must keep in mind is that we do ask that you produce another short video if you are the winner to give us a review of the amp. That would be great. That one's going to be kind of hard to enforce, I guess. I mean, once we get the amp to you, how are we going to show up at your house and be like, give us the freaking video of you playing the damn thing? That one we're going to, in good faith. The hope is that you're going to love it so much that you want to show the world anyway, but we're kind of setting it as a requirement, as an expectation that if which is part of the reason why we are doing the entrance video, if you will. It's kind of a way to show that you're willing to do that, that little bit more once you win. So I hope that seems fair. Those are really only the 3 rules. Ancillary to that, obviously it makes sense that you need to be able to accommodate the head. I'm not sending the whole thing, a cabinet and all that stuff. You're getting a head. So this is not a combo amp. So there's probably no point in getting in the game if you don't have a cabinet to run with it. Or, you're in an apartment that you couldn't turn it up even if you wanted to. Like you need a headphone amp or something like that. Ideally, you need to be able to accommodate it. Now, I'm not going to police that. That's going to be John's job to kind of manage the giveaway side of it. I'm here at this point from now on more or less to try to help promote the giveaway and to give you the content on the build. So we're going to just, like this here, we're going to spend a couple hours here and there, and you're going to watch me put holes in metal, stuff those holes with other parts, and create what you just kind of saw on that layout there and the schematic and put it all together. So, yeah, I'm going to check that out, Riley. Thank you for pulling that up. I'll look into that a little bit more. It makes sense. I can see why having it, not wired in makes sense, but I'll check that out. Then again, I might just run it as a parallel triode again too. So I kind of like parallel triodes. The Matchless Chieftain, we're kind of going off topic a little bit here, but the Matchless Chieftain actually runs like 3 or 4. I think it's 3 gain stages like that, where they're all parallel triodes. And I played one of those amps many years ago. It's actually a pretty cool little amp. I think it's at least 2, and then he goes into like an effects loop, and then he recovers with a parallel triode, and then it goes into the thing. Something like that, but whatever. In either case, I might do that because it would make sense, because that technically would be the driver. That tube would be the driver going into the effects loop. So it probably wouldn't hurt to have that one as a parallel triode. Yeah. But BC Electronics, thank you for coming in. Everyone, thank you for coming in. So that is kind of where we're at with things right now. Time-wise, if everything goes really smooth, it really won't take too long to get the amp itself built, which is great because then we can start doing some sound samples and kind of get you an idea of where it's going to be in terms of sound. Hopefully, it doesn't require too much R&D to finish up how it's actually going to sound for the finished product. That could be a big gotcha on this one. So tentatively, we're shooting for middle of the year. So May, June, possibly July. I'm hoping much before then. In theory, it should only take me a few months to do this. In theory. The cabinet, I'm getting better and faster at doing it, but that doesn't mean that it's going to be faster necessarily. So the cabinet is the thing that usually takes me the longest, but I've gotten a pretty good system down, so we're hoping that part's going to go quicker. I would say at the shortest end of the deal, possibly April, we can start thinking about shipping this thing off to John, where he will hold on to the amp for a little bit, do some demos of it, kind of get a taste for it, and then we'll figure out from there. April probably at the earliest though, and more than likely May or June. Be prepared for the actual giveaway. And obviously, we'll have a video series on this, so you'll get to see it literally being done in real time. That's going to be the painful part. And with that, I think we kind of nailed everything down. So if you're interested at all in this, do get subscribed and click the bell for notifications. Donations are, granted or welcomed, I guess you could say. I would love to continue to do this whole giveaway thing, refine it a little bit too if I can. I have a subscription thing. Any little thing like that will help make this more of a reality more often. If it doesn't seem, the first one was a little rough around the edges. I'm hoping this giveaway goes a little bit smoother, or a lot of bit smoother, to be honest. If by the third time it just turns out to be more of a headache and I'm going to spend the kind of time and money that I am to build these things, I may have to get away from doing giveaways. But donations, super chats, etc., stuff like that, subscriptions, whatnot, anything that can help kind of take some of the burden off will make it a lot easier to produce these things more often, and make it so I don't even have to turn this into a business. More or less, it just kind of self-perpetuates. That would be cool. That's the plan at the moment, is to try to make this thing so it's self-sustaining at least. And basically, you don't ever have to pay a dime for the things. I'll just continue to do giveaways until the end of time. But that kind of really just depends on how feasible it is. I don't have unlimited funds, so that's all there is to that. I've beat enough of the dead horses, so I am going to say thank you and bid you all adieu. I thank you so much. Take care, everybody. We'll see you on the next one. Goodbye. And it didn't fire. It was supposed to fire. Hold on, let's try this one last time. Ready? Goodbye.